So in this video, we're going to talk about the power rule and then the reverse power rule, which is power rule for integration. So let's do a little bit of a recall. How do I take the derivative of a variable raised to some number n, where n is just some any real number? Well, to take the derivative here, I take the exponent n, and first I bring it down and I multiply by this x to the n. So this becomes n times x to the n. That's step 1 in the power rule. Step 2 in the power rule says subtract 1 from the exponent. And if I subtract 1 from the exponent, now I have the derivative. Okay, so we've seen that several times. Even if I've got something weird like x to the pi, that derivative d dx here gets me pi times x to the pi minus 1 in the exponent there. Okay? So what I want to do is I want to do the opposite of the derivative. I want to do the integral. So I'm going to integrate x to the n here. So when I integrate this, the rule says, number 1, I add 1 to the exponent. So I'm going to add 1 to my exponent here instead of subtracting it like I did here. And then number 2, I'm going to bring the exponent down. So just like I brought the n down here, I'm going to bring this exponent down. But instead of multiplying, I'm going to divide. And so I divide by n plus 1. Now, and then I add my plus c here because whenever I do an indefinite integral to get that class of integrals, I need to add the plus c for all the different possible integrals that this derivative has. Okay? So, one thing that I can't do is whenever I'm dividing, I can't divide by 0. So n plus 1 equals 0 whenever n is equal to negative 1. So I need to not have n equal to negative 1 here. Okay? And if you think about it, n equal to negative 1 is this here. So that's 1 over x. And so I don't know if you can think back or not, recall this. What gives us a derivative of 1 over x? Well, if you think about it for just about a second, you can remember the natural log of x has a derivative 1 over x. Okay, so if n equals negative 1, then the integral is ln x plus c, an absolute value for the x. Now, how do I remember this rule here? Because it is a little bit strange. I think about it at like socks and shoes. Okay, so you're like, well, what do you mean socks and shoes? Well, I'm trying to think of something you do every day, maybe, right? So maybe every day you put on socks and shoes, right? Everyone knows how to put on socks and shoes. When you put your socks and shoes on, what's the first thing you put on? You put on the socks, okay? And then you put on the shoes, right? So once you have that on, at the end of the day, what's going to happen? Well, when you get home from the day at work or school or whatever, first thing you do is you take off your shoe, okay, because you had your shoe on the outside of your socks, right? And then you take off your socks, all right? So the opposite of putting on your sock and then put on your shoes is to take off your shoe and then take off your sock, okay? If you think about it, you put your socks on, then you put your shoes on. The first thing you take off can't be your socks. You got to take your shoes off first, then you take your socks off. This is how math works in the same inverse operation. So pretend like we got to take the shoe off here, okay? And then I can take my sock off, okay? Now, going one step further, to undo the mayhem I just did, instead of taking my shoe off, then my sock off, I put my sock back on here, and then I put on my shoe. Okay? So the idea here is this: subtraction and addition are opposites of each other. So to undo the taking off of the sock, to put back on the sock, I add. Okay? Opposite of subtraction is addition. And to undo the taking off of the shoe, of multiplying, I divide. Okay? By putting back on the shoe, the opposite of multiplication is division. So if you think about it numerically, if I start at 1 and I make it to 2, now I want to reverse that operation of what I did. So I have to start at 2 since I made it to 2, right? And then I work my way back to 1. So to get from 1 back to 1, these are the steps, okay? So take off the shoe, take off the socks, put back on the socks, put back on the shoe. So the inverse operations do opposite things in opposite orders. So here it was 1, 2, and then here it was 2, 1. And so I did multiply, subtract, and then I had add, divide. Okay? So I want to use this formula here. So if you can't remember anything else, just memorize this formula right here. This is what you need to know, right? So I'm given the indefinite integral x squared dx, and I want to integrate this. So in order to do this, excuse me, in order to do this, I need to add 1 to the exponent. So x squared plus 1 here. And then once I add 1 to the exponent, I divide. I divide by the exponent plus 1. And so what do I get? Simplified, this is x cubed over 3 plus c. Now, let's try one a little bit more complicated. What's the difference between this and this? Well, instead of just one integrand in here, I have this whole thing here is one integrand, but I have minus, plus, plus. I can break this up here, okay? Addition and subtraction, I can divide and conquer, all right? So just so you know, if I have the integral of f plus g dx, this is equal to the integral of f dx plus g dx, okay? So I can break this up over addition and subtraction. So all of this in here, I'm going to break up into 1, 2, 3, 4 indefinite integrals and divide and conquer this problem. So the first one here, what I'm going to do is have the 4x by itself here. The next one, I'm going to have the negative 2. The next one, I'm going to have 1 over x cubed. And then the last one, I'm going to have the square root of x. So I have 1, 2, 3, 4 indefinite integrals. I'm going to do each one of them. So I've split it up, divide it, and conquer it. All right, it's easier to divide things into pieces if you can, and then take it on the individual parts of the problem. That way you can complete the complicated mess. All right, so the next thing I want to do is I want to pull the constants out front. Just like with a derivative, when I had like the derivative of like 17x squared, I could take the constant 17 and pull it out front to take my derivative of x squared. And so then you just have 17 times 2x, right? So I'm going to do the same thing with integration. I'm going to take all my constants and pull them out. So the first constant I see is the 4. So I'm going to pull the 4 out front. And then what does that leave me? That just leaves me x dx inside. This next one, I have a negative 2. So I'm going to pull a negative 2 out front. And then what does that leave me? That just leaves me a dx. So I can put a 1 for a placeholder in there, 1 dx. The next one, I don't have any constants to pull out. Now, technically, 1 is x to the 0, right? So you can think of it like that, okay? Now, this one here, I'm going to simplify this because the power rule, in the same way when we took derivatives, like if I was going to take the derivative of 1 over x cubed, the first thing I would do is convert this to be d dx x to the negative 3, okay? Take the exponent that's positive, do the reciprocal, and all of a sudden that positive exponent becomes negative. That way we can use our rule rather easily. So this is x to the negative 3. And then this last one here, remember if I have a square root, it's understood with a square root that there's an index 2 here and there's only one x. So remember, the rider goes on top and the horsey goes underneath. So 1 over 2 for my exponent for a square root. So that's x to the 1/2 there. Now what I'm going to do is I'm going to integrate. So whenever I integrate here, how do I do it? I add 1 to the exponent. So when I add 1 to 1, I get 2. And then I divide by the exponent, 2. Okay? The next one, I add 1 to the exponent, so it becomes x to the 1. And then I divide by it, and it's just 1 in the denominator. Here, this is a little tricky for some people, all right? When I take negative 3 and I add 1 to it, what do I get? Yeah, negative 2, okay? And then I divide by negative 2. And then my last one here, this one's kind of tricky. 1/2, I add 1 to it. I do not want to see 1 and 1/2. That's no bueno, no mixed numbers, okay? Get a common denominator if you need to, or just use your calculator, I don't care. This is equal to 3 over 2, okay? So when I add 1 to 1/2, I get 3/2, and then I divide by 3/2. Now remember, dividing fractions is as easy as pie. All I got to do is flip and multiply, right? So I flip the denominator, I do the reciprocal, and then I multiply, okay? So hopefully that doesn't trick you up. Dividing by 3/2 is the same as multiplying by 2/3. Okay, so let's run through that real quick. Simplify this. 4 divided by 2 gets me 2x squared. And then this is just negative 2x. And then I have a negative 1/2. And then exponent of negative 2, I can flip to the denominator and make it positive x squared. And then once again, this keep, change, flip, right? So I keep the numerator the same, 3/2 for the exponent, multiplied by, keep, change division to multiplication, and then flip the denominator 2 over 3. Multiply that together, and we get 2/3 x to the 3/2, and then my plus c there, okay? Very important that you remember to put the plus c. Probably one of the most common things forgotten. I still remember to this day. We had my Cal 1 test for integration. There were 15 questions on it. I remember there were 15 questions because I made a 90 on the test, and it was because 10 of them involved writing a plus C, and I forgot all 10 plus C's, okay? So it took off 1 point for each plus C. So please don't do what I did and forget that plus C whenever you do all this beautiful work. The easiest part is to write out that plus C to the side. So don't forget that. Now there's an easy way to check. All I've got to do is take the derivative of this thing. And if I take the derivative and it equals this, then I know that I did the problem right. Okay, so it's pretty cool. It's kind of like whenever you were in college algebra and you learned first how to distribute. So you had like x minus 3 or x minus 1, x plus 3. You learned how to multiply this out, right? So I double distribute. I get x squared, I guess, minus or plus 2x, and then actually minus 3. And then once you learn how to multiply it out, what'd you do next? You learned how to do the opposite. You learned how to factor this, right? Whether it was the AC method or just guess and check, whatever you did, you figured out not only how to go here, but also to go right back to the factored form, okay? So we're doing the same thing in calculus, except for first we learned how to take the derivative of a function, okay? So we learned how to take the derivative of x squared to get 2x, right? And now we learn how to take the integral of a function, and whenever I integrate, I get what? I get add 1 to the exponent, I get x squared divided by 2, and then plus c, right? And that's where it cancels. I get x squared plus c. The only thing I'm picking up, though, whenever I integrate, is I get that constant plus c. Because if you think about it for just a second, you realize that x squared plus 10, x squared minus 32, all those derivatives, the derivatives of each of those functions, all give you 2x. Okay, so that plus c captures all the different possible antiderivatives. Okay, so the easy way to check is just to take the derivative of my function. So I'm going to take the derivative of this. So the derivative of this is just 2x times 2, and then negative 2 times x to the 0. And then this one here might be a little bit trickier. I would look at this form. I would look at that form there. And then power rule says bring the negative 2 out front. Well, guess what? The negative 2 cancels that negative 2. And then I have a negative 3 left in place. So those are going to cancel each other, right? By design. And then the last one. Okay, that's wrong. That should not say 0 there. I don't know why I wrote 0. The derivative of this is x to the 1/2. Okay? And so, sorry about that. That should be fixed there. This is plus 2/3, and then I have what? Multiplied by 3 over 2, x to the 1/2. Well, guess what I know about this? And these things right here, those cancel, right? And so then I get x to the 1/2 there. Okay? And it just so happens that this exactly matches what was right here. Okay? So really all I'm trying to say here is that if I have a function f of x and I take the derivative of the integral, I get the original integrand inside here. Okay? And this is a foreshadowing of the fundamental theorem of calculus.